Okay, so today we're learning about exponents, otherwise known as powers or indices. So if I said 2 squared, you know that is 2 times 2 equals 4. If I said 3 squared, 3 times 3 equals 9. 4 squared, 4 times 4 equals 5 squared. 5 times 5 equals 25. Okay. Moving on. If I said a number squared, that would be the same as a times a. Does that make sense? Right. If I said 4 cubed, do you know that means 4 times 4 times 4? Yeah, okay, that's cool. So if I said a cubed times a, would anyone have any idea what that would be? Yep. A times a times a for this guy here, and then times a. And how could I simplify that? Write it in a tidier fashion. Yep. A to the power of 4. Okay? So it's like you're multiplying the same number together lots of times. There's a shortcut, a short way of doing it. As soon as we get onto these, sometimes it gets confusing between multiplication and addition. So you can do these ones, you can do the addition ones, but then when you put them together it gets confusing. So I'm not going to put addition yet. I'm going to try something else. If I have 3a times 2a, what would that be? 6a squared. Okay, because it's 3 times a times 2 times a, which is the same as 2 times 3 times a times a. And a times a is a squared. Okay, that's what I mean by getting confused, because it's quite a different kind of a thing than when we did 5a plus 2a. What's that? 7a. Okay, so if we've got 5a plus 2a, we've got a plus a plus a plus a plus a for the 5a. 1, 2, 3, 4, 5 plus 2a is 7a. Okay? Copy that? Good. Alrighty, so now moving on really carefully. If I have 2a squared plus 3a, what's that? Yep. Is this and this, are they like terms? No, because a squared, whoops, Control Z, a squared, sorry, get the colour right, a squared and a are not the same number, so we can't collect those like terms. If we had 2a plus 3a, that would equal 5a. And if we had 2a squared plus 3a squared, that would equal 5a squared. Because we've got a squared plus a squared plus a squared plus a squared plus a squared. So we've got 5 lots of a squared. Okay? Hands up if you're alright? Yeah. So this is where it gets really tricky, because what did we decide about that one here? They're not like terms, so we can't add them. However, with multiplication, 2a squared times 3a That's the same as 2 times A times 3 times A, which equals 2 times 3 is 6, A cubed. So although they're not like terms, it doesn't matter when you multiply. Mix it all up together, it's not a problem. There's no cannot mix with the multiplication. But with addition, it's like no can do, that's it. Can't add them. They're not like terms, but here I can multiply anything. Make sense? Okay, so let's have a look at what the exercises you're doing today. They are a little bit tricky. I'll give you one example. Is 6 times A minus 2 times B times B. Now you're really working with your bed maths, meaning brackets first, then exponents, then division, multiplication, then addition, subtraction. So what does it mean that we have to do first here? Multiplication. So we write 6A minus 2B squared. Then can we do anything? Are they like terms? No. So you can't go any further. Okay, I'll do a few more. So if we have 2 times P, can you simplify that? 2P squared. Okay. 2 times P squared times P cubed. 2P to the power of 5. Nice. P times P times P times P times P. What about x to the power of 10 times x to the power of 2? 12. What about x to the power of A times x to the power of B? A, think. What did you do to this and this to get that? What did you do to this and this to get that? What did you do with the invisible 1 and the invisible 1 to get that? A plus B. See how I mean that the plus and the multiplication can get very confusing, okay, as to which is which. So it's A plus B. So that there's actually the general rule, okay, and you'll find that in a lot of rule books, you know, where the rules are, okay, so that you've generalized it, which is brilliant. Okay, so you're on page 194. See how many you can do.